Good morning, sir. Today I'm gonna talk about the things that I have learned in our finals term. First, let's talk about how to read weather maps. Weather map, also known as a synoptic chart, are an example of an isolated map. Isolated maps are made of lines that join points of equal value. Contour lines drawn on a topographic map are another example of an isolated map. Weather maps use lines called isobars plus other symbols to join together lines of equal air pressure. 1013 millibars is the average sea level air pressure. Therefore, areas with an air pressure of over 1013 millibars are considered to be areas of high pressure, and areas with an air pressure below 1013 millibars are considered to be areas of low pressure. There are four types of front mostly common seen in weather maps: the cold front, warm front, occluded front, and lastly the stationary front. A col, also called a saddle point or neutral point, is in meteorology the point of intersection of a trough and a ridge. In the pressure pattern of a weather map, there are different types of col: the symmetric, anticyclonic, and the cyclonic col. A ridge or barometric ridge is a term in meteorology describing an elongated area of relatively high atmospheric pressure compared to the surrounding environment without being a closed circulation. A trough is an elongated region of relatively low atmospheric pressure without a closed isobaric contour that would define it as a low pressure area. Since low pressure area implies a low height on a pressure surface, dots and ridges refer to features in an identical sense as those on a topographic map. Next will be the coding and decoding of meteorological features. As you can see here behind my back are the parts of how to decode the meteorological features. First, we go to the BBXX, which is the identification letter for a weather report from a ship. Next is DD, a ship's call sign. YY, which is the day of month, GG, which is the time of observation, IW, which will be the wind speed indicator, 99 will be indicator figures of ship report, LA or the triple LA, latitude degrees and tenths, QC would be the quadrant of the globe, LO would be the longitude degrees and tenths, IR would be indicator of precipitation. The IX would be the indicator for weather map. H should be height of base of lowest cloud in the sky. VV would be horizontally visibility. Next is the 7, indicator for weather group. WW is the present with weather. Next is 8, indicator figure cloud group. NH is total amount of sky covered by low or medium if no low cloud. CL is a cloud type which is cumulus cumulonimbus. Next is the CM, which is the cloud type would be altocumulus, altostratus, or nimbostratus. Next is the CH, which is the cloud type would be cirrus, cirrostratus, or cirrocumulus. 222 will be the section indicator figure. DS is the course made good during the last 3 hours. 0 would be the indicator figure in sea temperature group. SS would be the sign and type of temperature measurement. TW would be the sea surface temperature in degrees and tenths. 2 would be the indicator figure of wave group. PW would be the period of sea waves in seconds. HW would be the height of sea waves in units of 1/2 meters. 3 would be the indicator figure direction of swell group. DW1 would be the direction from which first swell waves are coming in tenths of degrees. DW2 would be the direction from which second swell waves are coming in tenths of degrees. 4 would be the indicator figure for first swell of wave group. PW1 would be the period of first swell waves in second. HW1 would be the height of first swell waves in units of 1/2 meters. 6. Indicator figure ice accretion group. IS would be the type of ice accretion. ES would be the ice thickness in centimeters. RS would be the rate of ice accretion. 8 would be the indicator of figure of wet bulb group. SW is the sign and type of wet bulb temperature. TB would be the wet bulb temperature in degrees and tenths. Ice group indicator. CI would be the concentration or arrangement of sea ice. SI will be the stage of development. BI will be the ice of land origin. DI would be the bearing of principal ice edge, and ZI will be the ice situation and tend over preceding 3 hours. So this is an example of decoding messages. As you can see, the 14 coded as 14, 12 hours GMT coded as 12, and the wind speed estimated in knots is 3. So if we combine these 3, we get 14, 12, and 3. That's how you decode or code the meteorological informations. Weather warnings and forecast messages are in plain language. The meaning of these warnings are: for small craft warning, winds is about 20 to 33 knots and we have heights to 2 to 3 meters or 7 to 10 feet. Gale warnings, winds are from 34 to 47 knots and wave height of 6 to 9 meters or 20 to 30 feet. Storm warnings are from winds from 48 to 63 knots and wave height of 9 to 16 meters or 30 to 52 feet. Hurricane force warning are winds from 64 knots and over and wave height over 16 or 52 feet. So there are different types of forecasting. The first is the historical forecasting. It is predicting the weather by assuming that what happened in the past will happen again in this time. One of the methods is used to predict the tracks of hurricanes. Persistence forecasting is often reliable over periods of minutes or hours. In most locations, persistent forecasting doesn't work well for periods of longer than a couple of hours. Because of the temperature and clouds cover often vary greatly between morning and afternoon and evening, and between day and night. Trend forecasting is a more reliable, versatile method of short-term forecasting. Involves the assumption that a current tendency or trend will continue or that observed cycle will repeat. Synoptic weather forecasting is done by assembling weather maps of large regions from observed and reported data at numerous stations. Numerical forecasting is more like a digital communication in which the variables are broken up into small parcels or packets, and the behavior of the whole system is deduced by true force calculations. Based on the laws of physics on board, seafarers have available number of documents and maps able to provide a meteorological information required for practicing a safe navigation. So, next, we should talk about how to name a tropical cyclone. Tropical cyclones can last for a week or more, therefore there can be more than one cyclone at a time. Weather forecasters give each tropical cyclone a name to avoid confusion. In general, tropical cyclones are named according to the rules of regional level. Nations in the northern Indian Ocean began using a new system for naming tropical cyclones in 2000. The names are listed alphabetically country-wise and are neutral gender-wise. The common rule is that the name list is proposed by the National Meteorological and Hydrological Services of WMO members of a specific region and approved by the respective tropical cyclone regional bodies at their annual or biennial sessions. In naming the different types of cyclones, there are institutions in naming the cyclones. In the North Atlantic, in the Eastern Pacific, and the Central Pacific, we got the United States of National Hurricane Center. In the Western Pacific, we got Japan Meteorological Agency and PAGASA. In the North Indian Ocean, we got India Meteorological Department. In the Southwest Indian Ocean, we got Mauritius Meteorological Service, Mateo, Madagascar. In the Australian region, we got Indonesia Agency for Meteorology, Climatology, and Geophysics. And also Papua New Guinea National Weather Service and Australian Bureau of Meteorology. In the Southern Pacific, we got Fiji Meteorological Service and Meteorological Service of New Zealand. And lastly, in the South Atlantic, we got Brazilian Navy Hydrographic Center. The practice of giving storm personal names appears to have originated with Clement Ragg, an Australian meteorologist who in the 1890s entertained himself by naming storms after women, mythical figures, and politicians that he didn't like. The modern system of using personal names developed during World War II when meteorologists began using women's name, often those wives or girlfriends instead of cumbersome designations based on the latitude and longitude. Male names were added to the list in 1979 when women's group pointed out the sexism of using only female names. So that would be all towards what I have learned and taught throughout this course in the finals terms in Meteorology 211. That would be all, sir. Thank you.